So today we'll do spatial database organization and management. What do you mean by spatial database organization? Is what is a spatial database? Okay. So what is a spatial database? So a spatial database is a database that is optimized to store query the data that is related to objects in space, including point, line, and polygon. So whenever we are trying to create any database in terms of GIS, we are trying to create a database where we can store the data, we can manipulate the data with the query the data, and what those data sets are. These data sets are in form of point, line, and polygon. While typical database can understand the various numeric and characters of the data type, additional functionality is to be needed for the database to produce the spatial data type. They are typically called as geometry of feature. So not only we are storing the spatial data, we have to also store the non-spatial data. We have to also store its property, and for that additional features is required, and those features are known as geometry or features. So what are this geometry in features? In addition to the typical SQL query like select, if you're selecting an object, create, when you're creating a point on polygon, or you're making a statement, or you're making a spatial database. So you need some spatial operations through which you can do various kinds of observation, various kinds of measurements, because finally if we are taking a satellite image, we want to use that satellite image in order to have some kinds of understanding of that area, and that understanding can be done only when you're performing various kinds of analysis means measurements. Without measurements, you want to measure the length of the road, you want to measure the length of the rivers, you have to map the watershed boundary, you have to highlight those points. So for that, the spatial measurement is required. And what does it does? It does the distance between point, line, and polygon. What is the area? What is the distance? Then what other features is required? You require special functions. Special functions means modify existing features to create new one. So maybe many times when you are digitizing, so you what you have to do, you will be seeing that you have taken some other area that was not supposed to be in X class, but here that has to be supposed to be in Y class, but by default or by mistake you have classified that into X. So what you will do, you will rectify the boundary and you will create a new boundary so that that perfectly fits to its original position. So such operation has to be also performed in spatially GIS database. Then what does spatial predicts? What does spatial predicts means? Allows true and false queries such as is there a residence located a mile in the area where we are planning to build a landfill. So what we are trying to do, we have to do various kinds of query. You have to put. So what you will to do, you will be doing a buffer lay analysis, so that we'll make a 500-meter buffer along the landfill, and then we'll check whether any settlement is there or any village is there. So such kinds of operation has to be done using buffer overlay analysis. So spatial database, you can see that a lot of operation has to be created, has to be constructed, and those features, those creation or those functions can be done only using various kinds of functions. So what are those functions? The first function is constructor function. So what does the construction purpose or function does? From the name itself, it states that it's trying to construct some functions. So what does it does? It creates new feature with an SQL sequential query language, that is a query specifying the vertices. So vertices are the points of a nodes, the points of a nodes, which will make a line. So whenever you are making a line, you see as a straight line, but when you convert that into a line, into nodes or into a vertex, you will see dot 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 dot. So what they are? They are connectors. They are one vortex is connected to the other vortex. The other vortex is connected to the next vortex. Some polygons are on the left, some polygons on the line, and each and every vortex has got its number. So that makes a line. So if the first and the last vortex of the line are identical, the feature can be of the type a polygon closed line. Means both are close to a same point where it started and where it end, then that is considered to be as a polygon. So the system identifies such feature through those functions that are known as constructor functions. Then other one is observer function. So what does from the term itself, it says that it observes. So what is the observation? Queries which return specific information about a feature such as location in a center of a circle. Like there is a lot of database that are available in a district level, like you're working at a district level, you've got a database. Now you want to see that in which block the maximum literacy rate is there, that is above 80% literacy rate is there. For example, there is a question that I want to see which are the learned blocks or the villages of that district. So I'll be putting those function that literacy greater than equal to 80%. So what will happen when I'll select the attribute greater than 80%? So out of maybe, for example, 500 blocks, 10 or 20 blocks will be selected. So that is known as observer function, that is observed on the basis of your questionnaire that you have asked to the system. So due to this spatial characteristics and specific query requirement, means we are doing some specific kinds of point, line, polygon, and then we are spatially querying some specific query. A standardized database management system may not be sufficient for storage and management of spatial data. So if you are working and we are trying to do and create a simple database system, that is insufficient to solve our problem. However, many industry standard RDMS, that is relational database management system, that we have already studied, are now supporting spatial objects inside relational database management systems. So what does a spatial database creates, or what is the background? The spatial database provides structures for storage and analysis of spatial data. So when we are creating a spatial data, what it does? It provides the structure, it provides the storage, it provides you the platform where you can analyze the spatial data. So what this spatial data is comprised of? This spatial data is comprised of object in multi-dimensional place. Means it can have x, it can have y, it can have z. So that is multi-dimensional space, and storing of this spatial data in a standard database will require excessive amount of space. So if you are going to store the data sets, you will see many times the it takes lot of space in your system. In the same way, if you are working at a nation or as a country or as a world as a whole, a large storage space is required for such kind of analysis. So what we have to do? We have to create a queries to retrieve and analyze the spatial data from a standard database would be long and cumbersome, leaving a lot of room of error. So if we are trying to work with a normal database that we have dealt with, or we know in our day-to-day life exercise that we are doing, or we are storing the data set, that will be very slow operation, that will be too long operation, that will be time consuming, and many time whatever result that is displayed on your screen has got or will have a lot of error. But when you will create a spatial database, the amount of storage, the amount of retrieval, the amount of spatial analysis of the data sets will be very high. That's why we'll be focusing more on creating a spatial database rather than creating normal database management system. So what are the database that has to be stored in a, spatial database? One is geographical latitude, longitude. The other one is Cartesian coordinates. Then we have to save the network analysis, because each and every nodes are connected, vertex are connected, so they are the forming a network. So all those networks are connected. Then you have to preserve the direction, because in map you have to preserve the scale. The four properties of a map should be preserved in this spatial data, all the four, whether that is direction, scale, projections, latitude, network, all has to be protected in this spatial database. So what does 3D database means? 3D database means you have to store the weather data, you have to store the coordinate system, you have to store the topological data, you have to store the satellite imageries, whether that is 1D or 2D. So there are some of the examples of data sets that has to be stored in the spatial data. So what does this spatial database connects of, or what we are talking about? SDMS, that is Spatial Based Database Management System, is a database management system, but that is a advanced database management system where we are storing the spatial data and non-spatial data. So it offers spatial data type, data model, and query analysis. And it supports all the spatial properties and operation. It supports spatial data types and its implementation, whether that is point, line, or polygon, and supports spatial indexing, whatever indexing you are providing, whatever ranks you are providing, whatever algorithms what you are providing can be attached together. We can perform various kinds of mathematical operation on those spatial databases. So you can see that how this database are represented. So you can see the spatial representation. This is a raster model where you can see these are the various features that are road. Then you have got houses. This is the raster data model. In the same way, if you are creating a vector of the same raster data model, this is how that has to be described. This is a river, this is a house, and all this model has to be stored in your spatial database, whether that is a vector model or whether that is a raster model. So when we talk about a spatial data type, we are talking about point, line, and polygon. So what is point? Point is a two real numbers. Line is a sequence of point, and region is the area included inside the endpoints. So that is how the system recognizes the point, line, and polygon. So what are the examples of a database? An example of a database is a relational relationship. It can have a state name, it can have city name, it can have a river name. So here is the state name. State name will be in the form of string. The area will be in the form of region, and the number will be in the form of integers. In the case of cities, the city name will be in stream, the center will have a point, and the extension will be in the form of polygon. In the same way, if you are making a river, it will be in the form of string, the river name, and that has to be disguised. Either if the width is high, you will be disguising it in the form of polygon, and if the width is less, you will be performing it in the form of line. So what you are doing, you are trying to do or trying to highlight. So what you are trying to do, you will be selecting from river where root intersect are. So what is select? Select from river means select what the command is given to the system. So system will select C name. C name is your string name. Then S name from the city. Then state where it flows, from where it's going. So all such kind of operation, length, intersection, what is the root, all the command and intersection, all the formula that you are putting will be displayed in your display. So the basic behind what we do in as a lab exercise in our ArcGIS practical or any GIS practical or any database is the logic what we are putting, and this logic has to be stored in the form of strings, in the form of commands, in the form of database. So what does spatial queries means? Spatial query means we want to get our area of interest. We want to get a answer to the question that we are searching for from the selected database. Like if we want to query what is the query command that I want to know? Find all object inside query Q that intersect north. So what will happen? It will run the nearest neighborhood query and it will find the closest object to the query point Q, because we have asked to find all the objects. So when you're finding all the objects means we'll be finding those features which are nearest and closest to the object for which we are searching it, and finally you will be providing a two feature that fits perfectly to the command, and finally a result will be displayed on your screen. So spatial indexes, it is used to speed up spatial query. So whenever we are providing an index, it is more easier and it makes the more things simpler in nature. What we are doing, we are providing indexes to those raster data. That's indexes, as we have already studied, is based on recursive subdivisions of the space. Example, quad trees. Then we have got indexes for vector data that differ depending on the type of data, means extension of the quad trees are used also for vector data customization. So vector, how we are doing this vector data indexing. So different indexing methods are used for point, line and polygon. In case of collection of polygons, instead of indexing the object geometric themselves, whose shape might be complex. So many times when you're making a polygon, the shape might be complex. So we consider an approximation of the geometry and index is instead. So what we do, the most common used is approximation, that is minimum bounding rectangle, that is MBR. So whenever you're putting it, those boundaries are stored in the form of minimum boundary box in database management system. So what is this MBR? By using this MBR, the geometric key for building the spatial index is saved, and we save the cost of evaluating expensive geometric predicts during index traversal. As geometric test against an MBR is constant, so point in polygon test can be easily done, and in addition the space required to store a rectangle is constant at two places, whether that is point in polygon, whether that is polygon in polygon. So what is MBR? So MBR is an operation involving a spatial predict on a collection of object indexed on their MBRs, is performed in two steps. So we'll be performing this MBR in two steps. One is filter step. So what does, and the other one is refinement. So what we do, just like in our digital image processing, first we'll just select the object whose MBR satisfies the spatial predict by transposing the spatial index and applying the predict to the MBRs. And secondly, the refinement step, that is the object that pass the filter step are a superset of a solution, and a MBR might satisfy the predicate but the corresponding object might not be. So that are the steps through which you will be indexing it. We have already studied many of the relational based topics in our earlier classes, that is quad tree, octree, jubil tree, R tree, R plus tree, R square tree, Hilbert R tree. So this more popular methods in this SDX, that is spatial based data, what are this coordinates. So spatial database uses and who are the user and who is types of uses. One is manage spatial data. So geology, whether geomorphology, land use, land cover. So all the data will be taken involved, lot of manpower is involved, lot of research is involved, and until unless nobody is using that resource, that is of no use to any government. So such type of uses must be for this spatial database users and modeling. Now, what does a spatial database management system does? The spatial base database management system provides the capacity of a traditional database management systems, that is DMS, while allowing the spatial storage and handling of spatial data. So whenever we are talking about a spatial database management system, DBMS is the same that we used to do or which we are working in our day-to-day exercises or practicals that we have done in our laboratories. The only thing that adds on to this database management system is the spatial storage, how the data sets are stored in order to get the minimum space or storage is taken to the system, and handling of this spatial database. So what does a spatial database system do? It works with an underlying database management system. It allows spatial data models and types, supports query language specific to spatial data and types, provides handling of spatial data and operations. So all these functions are being performed by spatial based database modeling systems, where it allows all the work being done, query handling of spatial data. Only what we are adding to our existing database management system, that is the spatial data, their type, their functionality, their operation, their working condition, their support system, their languages, all has to be stored and has to be deployed in. So SD BMS is a three-layer data structure. How this is a three-layer data structure? As SDMS works with a spatial application at the front end and DBMS at the back end. So whenever we are working up, whenever we are creating a GIS, we are creating a point, we are creating a polygon, we are creating a line. So we are, our mind is more particular or more associated, or it connects to the point, line and polygon. But at back end, whenever you're creating a point, line or polygon, parallelly the database management system or DBMS is parallelly created on all the identifiers, all the indexes, all the attributes of those features what we are creating in the GIS environment or in the GIS domain is automatically saved in the form of database management system. So what is this spatial database management system? Comprises of three layers. The first is interface to spatial application. So first important thing is you need a software, you need a interface where you can create this all databases together. You can create a point data, you can create a line data, you can create a point data. The second one is core spatial functionalities, like what are the important functions that you are going to perform using this SDMS. And finally a connection between the data that you have created through the interface, and finally how you will be applying those spatial functionality to create and to record the data sets in the DBMS, so that finally the data can be stored, the data can be managed, the data can be analyzed, and finally we can utilize this database management system for further planning and processing of the databases. So how does this SDMS is three-letter data structure? You can see that at the starting you'll get a DBMS that we already know. Then you have got an interface to DMS, DBMS, where you will be creating an interface, some tools, some techniques, some icons, and then you will be performing some core spatial functionality. You will be performing some spatial analysis. You will be doing. So, what kind of spatial analysis you're trying to do? You will be trying to create a taxonomy. You will be trying to create the different types of data model, whether that is a raster data model and their features, their attribute, or that is a vector data model, their features, their attributes. Then you will be performing the various kinds of operation has to be performed, whether kinds of overlay analysis, buffer analysis, all the mathematical equations, weightage will be performing all those operations in operations command. Then there will be a query language where you will be asking the database query from your database. Then you will be selecting those query from the data, then you will be exporting it, or whatever the application is, you will be doing it using this query language. Finally, you must have some algorithm, because all the data sets, whether you're saying about NDVI and DWI or whatever filters you're using or whatever age enhancement you're doing, that is based on different algorithm. So all those algorithm dictionary must be updated, must be used, because you have to use those functionalities for creation of the various databases. And finally, assess more to all the users, whether you're sitting in Japan or whether you're sitting in India, whether you're sitting in Bangladesh. You must provide, if there is no data security issue, you there must be option of how to message the data set, how to assess the data set, how to manage the data set. And finally, that data sets and all the functionality that we are going to create in our DBMS will connect it to your spatial applications, whether whatever your objective is, whether it's for water conservation, glacial hazards, avalanche mapping, forest fire donations, public health hazard delineation, all such studies, all such topics that comes to your mind can be easily evaluated using this spatial database management system, where you have got a connection between the DBMS, you are creating an interface with a DBMS, and finally you're creating it through the spatial application. So we are working in this blue line, and we are least bothered, and we don't get care, or we are not knowing the basic understanding how this ash color and how this yellow color data are being stored in the computer or through software, and what are the operations are doing. So by reading such topics, by searching reading, that's why spatial database modeling and the decision support system has been added to your course curriculum, so that you can know the backend operation, the backend methods, the backend terminology, the backend methods, types, datas that are used for creation of database. So what are the spatial query language? There are number of specified adaptation of SQL. So you have got various kinds of languages. You have got a spatial query language, where you will be doing the query related to the geographical latitude, longitude search. Then you have got temporary query language, that is TSQL2. Temporary means temporal means you will be doing the research related to what was the change in 1950, what was changed in 1970, 80, 90, 2000, 2010, 2020, and what is this going to happen in 2030. So such kinds of analysis, such kinds of query can be done using this temporal query data. Now you've got object query language. Object query language is related to any particular object, like it has got more precise, more higher accuracy. Like if I'm concentrating to my only concert is on a smart city, so I'll be concentrating myself to few objects, and through that I'll be using this object query language. And finally, object oriented structured query language, that is known as O2 SQL. So what are this spatial query language and how it is done? There are three types of queries or queries that can be done. The basic operation on all the data type, that is which is empty, what is the envelope and what is the boundary. That is the type of query you can do using the basic type. Then the other query is on the based of your topology or any set operators, that is what is disjoint, what is touch and what is contains. They are the three operations that you will be using in this type of queries. And finally you will be doing the spatial analysis, that is based on your distance, intersection, then symmetrical differences. So all these features, all this command will be taken into consideration to solve this spatial analysis or topological analysis of basic operations that we are performing in a spatial database. So spatial relationship, what does it means? When we are talking about topological relationship, it says about contaminant, overlapping, etc. There are various commands that are inbuilt. So you can see that the A and B, the first figure is representative of a containment zone within A, where does B lies, and in the right hand side there is a figure which says what are the features that are overlapping to each other. So if there is two object A and B, so we can easily find out the common features that are being overlapped using this command. Then you have got a metric relationship where the distance between the object is identified, measured. What is the difference or the distance between point A to point B? If you are measuring it, so we'll get the exact measurement of that object. And finally, the relation data shapes, that where it is located, how it is located, all the properties of the directions will be stored in the relational directional database. So what is SDMS? SDMS. So the organizing and management of geospatial data. So whenever we are trying to organize, create, and we are trying to manage this geospatial data inside DBMS, that is Database Management System, or RDMS, that is Relational Database Management System, has most an exciting and challenging area for GIS professionals during last decade, and which is known as Spatial Database Management System. Now we know spatial data. Now we are going to know what do you mean by spatial database management system. So we are talking about, when we are talking about the spatial database management system, we are talking about geodatabase model. So we have already studied a lot about geodatabase model, but still we are going to revise and add on to our existing knowledge. That is, the geodatabase is the most common data storage and management framework for ArcGIS, and it combines geo means earth, spatial data, with database, that is data repository, to create a centralized data repository for spatial data storage and management. So whenever we are creating a spatial data or geo database, we are trying to create a centralized geo data repository or a directory where all the spatial data sets can be stored and can be managed easily. So it can be leveraged in desktop. We can use this in a desktop, you can use that in a server, you can use that in a mobile environment, and that allows the user to store the data in GIS environment in a central location for easy access and management. So anybody, if I've got a storage that is centralized in nature, so anybody sitting from anywhere of the globe, anywhere from the country, from the distance, at a village level, can know the data, can explore the data, can query the data, can update the data depending on the objective, depending on the licensing, depending on your vision and mission of the project. So GeoDays data model. So you can see that this geodatabase model can be a single user geodata model, and in that you will be creating the personal data model that is related to personal use, where I'll be creating all the data sets. In that they will be creating the data set, data signature, and will be storing all this multi-temporal, multi-thematic analysis in the single data use But when we are company making the database into the any company or any enterprises, will making that into a RDBMS, that is relational database management system, and that is more kind of a multi-user database management system, because where multiple people can parallelly work on the same data, and the amount of accuracy, timing, money will be very high. And if you compare that with the personal data, if I want to share somebody, that requires licensing, that requires a lot of infrastructure. That's why the big companies don't create single database structure. That is because that is a waste of time, that cannot be easily handled, and that is not multiple operated operation. That's why you have to use this enterprise geo database, where the multiple users can use the data sets parallelly together, and you can have a working group whose work will be decided, that this working group will digitize all the roads, this working group will digitize all the railways, this working group will work on the hydrology, the other on soil, the third one on geomorphology, the fifth one, and all can update the database, all can upload the database. The other team will go into the field and parallelly provide all the database related to the ground truthing. So what will happen? The amount of information, the amount of knowledge will be very high, the amount of accuracy will be very high, and it will be time and money consuming, and multiple person can work on the database together to create a real time data sets that can be updated, that can be manipulated, that can be analyzed. So mega projects of government of India or any major projects throughout the world are handled using this RDMS and RSD technology. So each and every geo database, you have got different kinds of geo database models available in the earth, and each and every database has got its own application, its own environment. So what does it does? So on one side we have written all list all the categories on the application that we are looking into, and on the side we have enlisted the model type. So if we go for the enterprise geodatabase model, the application is large scale enterprise application scenario is there. Then when it comes about data storage, the enterprise related is that models platform involves DBMS, Oracle, Post, GRE, SQL Server. Then management interface, it has got R catalog, it has got RDMS, then you've got ArcSD. Storage capacity depends on the server. Licensing ability, RGS for servers, enterprise, that you have got for different kinds of company licensing will change. Then supported operating system, because you are having a license version, so that can work in any platform. Number of concurrent users, that is unlimited editors and readers, because we are working in a major project network, it will be intranet or internet. Then differentiating characteristic, it's supporting version, supports multi-user editing, support spatial types, enterprise IT integration, all can be done using this enterprise geo database model. But when we work on spatial work group model, it is smaller in size when you compare that with a enterprise data model, where the data is stored is worked on SQL Server Express. The management interface is done on the basis of R catalog. The storage capacity is 10 GB. The licensing availability is ArcGIS Server Worker Group. Operating system Windows. Number of concurrent users is 10 editors and readers. That 10 persons can work together, not more than 10% together. And network application, it is on internet. And differentiating characteristics, support any version and supports multiple user editing. And the most popular and the data sets what we are using in our personal laptop is a desktop geo database. That is a small team or a single use. Generally we are working in a 2 to 3 persons in a group, or a small group. Then what is the data storage that is required? That is SQL Server Express. Then what is the management interface that is required for the desktop? That is our catalog that we are familiar with working day to day. Then what is the storage capacity? That is 10 GB. that is provided. Then licensing ability, you have got Arc Engine, you have got ArcGIS for desktop advanced, then you have got ArcGIS for desktop standard, the operating system Windows, how many number of users we are using together. It can be one editors and three readers, means three people can read together and one can edit. Network, it is on the basis of desktop and local network use. It cannot be on internet, it cannot be on intranet. Support any versioning. So post GIS model, so we know what we have done in the GIS SDM modeling. So now this post GIS modeling. So post GIS especially enables the post GRE SQL server, allowing it to be used to the backend spatial database for the geographical information, that is GIS, much like ESRI, SD, or Oracle special extension. So PostGIS follows the OpenGIS simple feature specification for SQL and has been certified as complement with the types and functions provided. So PostGIS development was started by Refraction Research as a project in open source spatial database technology. PostGIS is released under GNA General Public License user, and PostGIS continues to be developed by a group of contributors led by project steering committee, and new features continue to be added, as we have already studied in our portion ki how the apprentice, how the methods of QGIS is done. In the same way, it is being done in GeoBase database model. So PostGIS supports storage in GIS object. What are the storage type that allows we can store point, line, polygon, multi-point, multi-line, multi-polygon, geometry collection are stored. What are the features? So the features can be of any time point. It can be polygon, it can be multi-point, it can be multi-string, it can be multi-polygon, it can be geometry collection. Spatial predicts the determining the interactions of geometric using 3 into 3 Eisenhower matrix provided by GeoS soft library, followed by uh, followed by your spatial operators for determining spatial measurements like area, distance, length, and parameters. All those functions are inbuilt in your spatial database. Then spatial operators are used for determining the geospatial sets like union difference by different portal. Then you've got various kinds of commands that are existing. Then it supports all the spatial data and non-spatial data, and all the workspace has been allotted for the raster data for the its development. So how it is created? So form, whenever you create a database, it's form and entitled to be hold as country name, state name, population name, and geography. So create a table, country name, then state name, then population as an integer, then shape. All these polygon are stored in such a form that the according to your shape, size, name, source, all the data will be selected. Like find all the countries that borders on Costa Rica, to select country, then from which country you want to, where you want to go, and what is the product. So if you run such command, you will be getting your spatial query depending on your commands that you are writing on the screen. So what are the types of query? The function names for query differ across geodatabase. The following list contains the commonly used functions built in PostGIS, a free geodatabase which is a PostGRE SQL extension. In the terms of geometry, refers to a point, line, box, or other two or three dimensional shape. So what are the different kinds of queries? PostGIS will be doing distance, that depends on geometry. Then that is in the form of number. Then equals, that is again in the form of geometry, that is a Boolean number. Then disjoint, again it's a geometry, it is Boolean. Intersect, Boolean. Touches, geometry, Boolean. Crosses, geometry, Boolean. Then overlaps, geometry Boolean. Contains, geometry Boolean. Intersects, Boolean. Length should be a number, area should be a number, centroid will be a geometry. So this is the command that is stored, and which way it is stored in the computer. And finally you have got an application of those commands, whether you are going for urban planning, whether you are going for route optimization, fire pollution, utility services, smart city, smart developing, villages, smart rural villages, and other applications are VLSI design, then modeling of human brain. Then you can go for various kinds of operations that are being done today nowadays in medical sciences that are based on digital image processing, and finally the traditional applications that depends on multi-dimensional operations. So with this, I'll end today's presentation, and we have come to know after today's class what do you mean by a spatial database management system, what are its uses, how it is stored, what are the geodatabase model, what is the different kinds of geodatabase model existing with us, how the data sets will be stored, what are the advantage of SDMS over DBMS, what and how the SDMS is different from the DBMS or RDMS, what are the different libraries that are being created or being updated by various ArcGIS personals, how the database are stored, how the database are recognized in the database, how you have to select and perform the query from your database, how you will be handling the data sets, how you will be performing the various kinds of analysis using this spatial based databases, and finally this all operations whether you're performing on raster data or vector data will be handled together, will be analyzed together to create a decision support system, so that any person irrespective of its department, discipline, knowledge can work together as a team to create a urban information system or a village information system or forest information system or cyclone information system or desertification information system or water resource information system. So all such kind of resources can be handled, can be stored, can be modeled using this geodatabase model system. With this, I'll conclude my today's class. We'll have 10 minutes of questionnaire, thereafter examinations in your LMS, and thereafter we'll conclude the class. Meanwhile, I'll stop my recording.